a guide for A-level students. Let's start with the basics. Velocity is equal to a change in displacement divided by a change in time. Acceleration is equal to a change in velocity divided by a change in time. If u is our starting or initial velocity and v is our finishing or final velocity, t is the time it takes to get from u to v. And the area under the graph is the displacement s. The gradient of the graph is the acceleration a. We can find the equations for uniform acceleration, or suvat equations, using this graph. Using a rearrangement of acceleration equals the change in velocity over the change in time, we can find the change in velocity, which we know from the graph is v minus u. A rearrangement gives our first equation. Our final velocity is equal to our initial velocity plus the acceleration times the time. We know the area under the graph is the displacement of the object. In this case, it's area A plus area B. Area A is equal to a half times v minus u, all multiplied by t, because it's a triangle, and area B is equal to ut. Using our previous equation, v minus u equals at, we can get our second suvat equation. S equals ut plus a half at squared. Starting again at the addition of areas, we can take t out as a factor, as it is in both areas. And we can call u 2u over 2, because these are equivalent. Using this, we can get our third suvat equation. S equals v plus u, all divided by 2, all multiplied by t. If I substitute t equals v minus u divided by a into s equals v plus u over 2 times t, I find that s equals v minus u times u plus v divided by 2a. An expansion of the bracketed terms gives us v squared minus u squared all divided by 2a equal to s. A rearrangement of this gives our final equation, v squared equals u squared plus 2as. So here's some quick summaries. For a velocity time graph, the area under the graph is the displacement of the object, and the gradient of the line is acceleration. For a displacement time graph, the gradient of the line is the velocity, and a curved line shows a change in velocity, which must be an acceleration. Here's a summary of our equations. So, v equals u plus at, s equals ut plus a half at squared, s equals v plus u divided by 2 times t, and v squared equals u squared plus 2as. So, some examples. If a train is constantly accelerating for 30 seconds at 10 meters per second along a frictionless track starting at a velocity of 5 meters per second, what is its final velocity? Now we're going to use v equals u plus at. We know our u is 5, our t is 30, and our a is 10. we put these into the equation, we find that our velocity is 305 meters per second. Example 2. How long does it take for a rocket constantly decelerating for 300 meters from 300 meters per second to 20 meters per second? So we're going to use S equals V plus U all divided by 2 or multiplied by T. We rearrange this equation to make T the subject. We then input our values, remembering that our U is 300 meters per second and our V is 20 meters per second because we're decelerating. We find our time is 1.9 seconds. Example 3. If a man is at the top of a 20-meter tall building and throws a ball at 5 meters per second downwards, what is its velocity just before it hits the ground? So we're going to use v squared equals u squared plus 2as. So we rearrange for v and we then input our values of s equals 20 meters, u equals 5 meters per second, and we assume that a is the acceleration due to gravity, so is 9.81 meters per second. We find our final velocity is 20 meters per second. Example 4. This is a little bit harder than the previous examples. So, how long does it take for a car travelling at 25 meters per second, decelerating at 2 meters per second to cover a distance of 50 meters? Using s equals ut plus a half at squared, we will end up with a quadratic equation. 0 equals t squared plus 25t minus 50. So we're going to use the quadratic formulae to solve this, which I've given here, where a is 1, b is 25, and c is minus 50. Don't forget your minus sign. So we're going to get two answers from this. However, we know 1 is not possible because it's a negative and we're talking time, so we can't have a negative. Therefore, we find that t is 1.9 seconds. Thanks for watching, and I hope this has helped.